Hello everybody, today we're going to be showing you how to make this simple rail with a set of increasing gear size. These are fully mobile and they're fully 3D rendered. So if you do this, double click, you can see that these gears actually spin with each other at the proper ratios and everything. If you want to learn how to do this, stay tuned. We're going to get right into it. So the first thing we're going to do is new design. And I'm going to just close this because we're going to be doing this not exact, so I don't need to take measurements and things like that. This is going to be a tutorial on several different aspects of Fusion 360, including the insert McMaster car component, also the utilities add-ins, which come with some standard ones that come with Fusion 360. So to get started, what we're going to do is we're just going to create a sketch here. We'll put it on the bottom plane, make a rectangle. Then we're going to dimension this 2 inches by 16. Okay. Open up my sketch tab over here. There we go. Okay, so now we're going to take this and we're going to extrude it. I'm going to extrude it one side, make sure it's the correct side, yep. The distance is going to be 1/4 inch, and it's going to make a new body that is correct. So we're going to press OK. Now in this, we're going to make some holes. To do that, we're going to create a sketch, put it on this face right here, and we're going to recenter it. Double click the center scroller on your mouse to recenter the object that you're working on. We're going to put some circles here, and just put a couple of them wherever. You're going to need, let me think, 1, 2, 3, 4, 5. You need 5 circles, getting increasingly farther apart. So now we're going to do a couple of things. We're going to make sure, we're going to click equal up here in the constraints, and we're going to make sure all these circles are the same exact size. Now, we're going to make this easier, we're going to make a line from the midpoint, which you can see because it shows a triangle next to where you're pointing at. From the midpoint to the midpoint through the center like that. Now we're going to press the coincident constraint, and we're going to go center point line, center point line, and now we are going to space these out. So the first one's going to be this far, 1.5 inches. And now each one of these is going to be getting farther apart. But we need to know exactly how far apart to make the pins in the rail so that the gears mesh perfectly together. So to do that, we need to figure out the size of our gears. I am going to optimize the gear ratio and the number of teeth to make this as easy as possible. So I know that my gears are going to be sizes 1 inch, 1 inch, 2 inch, 4 inch, 8 inch. So, knowing that, you cut that in half to find the radius of each gear to what they call the pitch diameter, and then you cut that in half, and then you add that to the pitch diameter cut in half of the one next to it. And that is how much space you need to have between those two. So 1 divided by 2 plus parenthesis 1 divided by 2 and parenthesis would be 1. Oh yeah, we never made all of these coincident. That and that. That and that. 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 There we go. Now back to sketch dimension. We're gonna do. So this one's gonna be like I said, 1, 1, 2, 4, 8. So 1 divided by 2 is a half. 2 divided by 2 is 1. A half plus 1 is 1.5. 2 divided by 2 is 1 plus, this one was 4, so 4 divided by 2 is 2. So 1 plus 2 is 3. And then 8 divided by 2 is 4. 4 divided by 2 is 2. 2 plus 4 is 6. Now, we need to see, we're going to exit the sketch dimension so we can try to drag some of these around, because I see that we're still not fully defined here. We're not constrained. So, let's see what it's going to let me drag around. Ah, yes. We never set the diameter of the circle. So the diameter will be, if I'm not mistaken, 0.25. Now we are constrained. So we're going to finish the sketch. I'm going to extrude. We're going to extrude. I should just zoom in. That would make this easier. So we're going to extrude these two halves of all these circles. Okay. So we're going to go to cut. We're going to go to the thickness of this bar, which is 0.25. Except for when I go down, so it's negative 0.25 instead of up. Correct. Okay, so now we have this rail with all the holes in it, and we're ready to mount some gears on it. So we're going to save this. We're going to call it gear rail, and we're going to save. Now that we saved it, we're going to make a new document, and we're going to use something we have not used in the past, and this is the add-in under the Utilities tab. So you're going to click Scripts and Add-ins and scroll the whole way to the bottom of Scripts. And you're going to double click the spur gear that has the blue and yellow icon next to it. And it will bring up the spur gear window for creating spur gears. We're going to keep this on standard English dot metric. We're going to change this to 25 degrees, which is the cut of the gear teeth angle right here. The diametral pitch is the number of teeth per inch of the pitch diameter. The pitch diameter is this circle right here. This dotted line. Number of teeth is number of teeth. Backlash is not important. Root fillet radius, we're gonna make that pretty much like as small as possible. So we're gonna go to like 0.001. There we go. thickness of the gear is going to be 1/2 inch, so that's going to stay. Hole diameter is 0.25 because we made those other holes 0.25. So now all we have to change is diametral pitch and pitch diameter. Well, number of teeth. In this version of the spur gear tool, it doesn't let you actually change the pitch diameter yourself, which is fine because we can just set the diametral pitch and the number of teeth. So I want the pitch to be the same as the number of teeth. That way my pitch diameter will be 1. So my diametral pitch is going to be 10. My number of teeth is going to be 10. That'll make this 1 inch. So we're going to make that here. And there we go. Made us a spur gear. Should be exactly the right size for what we need. And so we're going to save this as year 1. Now we're going to make another design. We're going to use the spur gear tool again. (25°) English, pitch 10, number of teeth 20. 0.001. (1/4 inch hole). Pitch diameter should be 2 inches, which is exactly what we're looking for. Now we save this one. Gear 2. New document. Utilities, add-ins, spur gear. (25°) Diametral pitch 10. Number of teeth 40. 0.001. 0.25. Here's our 4-inch gear. Save it, gear 3. And the last one. As you can see, that's a pretty big gear right there. I'm going to save that one. Gear 4. Okay, now we can take up the gear rail and, oh wait, actually we're going to make one more thing. We're going to make a very simple new document. Create sketch, bottom plane, center diameter circle, dimension it 0.25, and then we're going to extrude 0.75, and that's it. That's all we're going to do. We're going to save that as pin. For the YouTube video that I'm making right now. And we're going to save that. And so now gear rail is what we're going to pull up. We are going to open our data panel right here, or we're going to select this object, and we're going to well, now I gotta figure it out. Okay, if we open the data panel, you see I have these gears in here from previously, but that's okay. We just called these gear 1, 2, 3, and 4, so we're gonna insert this into the current drawing. We're gonna do it again after we click OK. Then gear 2. And gear 3. and gear 4. And then finally, we're going to get the pin for the video. Okay. Now, I'm gonna take all these and unstack them. And now we're going to take the pin, which is this. We're going to right click the component. We're going to move copy, create copy. Okay. And then we're going to do it again. I'm trying to make sure there's not a faster way to do this. If there is, I'm sorry, but this is how I know how to do it at the current time. Create copy. Okay. Create copy. Okay. We need 5, so this is the last one. Create copy. Okay. And we're gonna unstack these. Okay. Now, we're gonna use some tools we've never used before, some more. We're going to put these nearby to the holes they're going to go in. And now we're going to zoom in on the first couple. We're going to press joint. So when you're using joint, you want to make sure you have a good view exactly the two parts that you want to join together. So right here is a decent view. We can see that that one's actually floating above the rail right now. So we're going to click joint, and then we're going to click this edge of this cylinder, and we're going to click this edge of that hole. As you can see, it joins them together perfectly. There's nothing we even have to do. And make sure the motion is set to rigid. Okay? Now we're going to do the same thing 4 more times. Joint, there, there, okay. Joint, there, there, okay. Joint, that, make sure it looks okay, okay. Joint, there, and there, looks good. Okay, now, if we zoom back out, you can see we have the pins sticking out. All those are rigid joints, so they will not move at all. They're just like joining two components together. Oh, that is one thing that I did forget to tell you guys to do. We're gonna go to pin. We're going to go to bodies, create components from bodies. And then we're going to go to gear rail. We're going to go to bodies, create components from bodies. Now these are actually components and not just designs. Not just hollow bodies. So we are going to mount each one of these gears to one of these pins. To do that, we're going to use the joint command again. We're going to keep it really simple. So joint this top top edge of the hole of the smallest gear, top edge of the cylinder that's sticking out. Perfect. That's all. Actually, that's not all we're gonna do. We're going to go over here to motion and change this from rigid to revolute so that it will revolve around the joint that is placed on. So we're going to press OK. Now we're going to do this again for the other small gear. Joint. And we're going to go, yep, that's correct, because it keeps the joint motion type in. Now, as you can see, these are inside. These teeth are touching and inside of each other. So we're going to double click the flag here and drag this until the teeth perfectly mesh up. And if you have to, you can use the fine tuning by actually typing in the degrees. I'm just going to go to 1 degree. Okay, so as you can see, these teeth now mesh perfectly. 18 degrees is what we had to do. Now we're going to do that again. And press escape. 18, enter. You're going to press enter. Joint. That edge. That edge. Yep. Motion. Revolute. Okay. That one looks like it's lined up pretty good. Yep, that one's lined up. Now we go to joint that. That. But that and that. Why is it moving the peg? That's very odd. Okay. No, just a little glitch because it moved it to the right spot. Now we adjust this. I'm gonna try 18. So now that we have that figured out, I don't really know why that was happening. So I apologize for that. I fixed it by grounding this piece. So I right clicked and then I clicked Actually, I found the component over here, right clicked it, and then I clicked ground. So now it's stuck in place, so it won't move. I should have done that to start with. But okay. New joint. There. And there. Good, it works. Motion is good. The joint looks correct. I think. Yep. So now we have our system of gears. And they all spin individually. They don't spin together. The first thing you might think is, oh, we'll just turn on, like, physics. You know, like turn on contact between objects. Because right now these just drag through each other. But if we try to enable contact, and then we try to spin one of these, what we get is, well, a broken computer. I mean, it's lagging my computer so bad that, like, I don't even know if the video is still recording at the moment. So that's what happens when you, that's what happens when you try to enable contact and make physics do the work. It's a lot of math for the computer to have to figure out all at once. Response, and with the response time that's acceptable. So we're going to turn off contact, disable contact, and what we're going to do is we're going to use something called motion link. We're going to capture this position. We're going to tie these joints together. So as you can see right now, they're not correct. That would be correct. And they look good. So as long as they look good, that's all there is to it. You're just linking the motion of the two different joints. So since these are the same size, we can keep the ratio the same. So they spin at the same rate. If we have two different size gears, such as these two, as you can see, even if we click reverse, this gear is still spinning too fast. The teeth are going through these teeth. So we need revolute 8, which is this, to spin slower. So for every time this goes around once, I only want this to go around half of a time, so 180 degrees. As you can see, the teeth meshed now. We're going to do the same thing here. Motion link, this, and this. Make the second one half as much as the first one. Okay. And one more. Whoop. Motion link. That and that. Reversed. $180. There we go. Now, to test it, get all the gears in view. Double click this joint, which is going to be trying to do a constrained orbit here, but it's not working. Okay, double click the flag and turn it. Make sure everything looks good. And you have yourself a working set of gears. Make sure you just click. Well, it doesn't really matter where you leave the gears. If you click escape or enter, it's not gonna make a difference. It's just gonna change the position permanently. But the gears will stay meshed because everything we have is all fully defined. Everything we have is fully meshed together and linked together properly. And so there you go. The last thing I wanted to show you is going to be well, I was going to show you a McMaster-Carr component. So since I promised that, let's do it real quick. New design, McMaster-Carr, and it's going to insert and then McMaster-Carr component. And it's going to take you to this. And here you can find the 3D files for, I'm guessing, millions or at least hundreds of thousands of components for various equipment, tools, nuts and bolts, hardware, stuff like that. This is all hardware up top, but there's tools, nails, staplers, gas regulators, pipes, plumbing, all sorts of stuff. So they have the 3D files for everything. And if you want to insert something into the design that you're working on, all you have to do is click something like I'm going to pick a pin. I'm going to pick quick release pins. I'm going to pick the flathead ones with the ball, the spring ball. Then I'm going to pick a size that I like. And I'm just going to click the number that's blue there. Make sure it says 3D step and then download. Give it a second. And there we have it. So that's how you can insert McMaster-Carr components into any drawing you want. Okay, well yeah, that's how you make a MasterCard component into Fusion 360. That's gonna wrap up this video. We have our gear rail finished with them gears meshed together. Showed you how to make a spur gear, all that. Thanks for watching. Please leave comments, like, subscribe, anything. Everything helps. I'm trying to get this channel off the ground, so thank you. Have a wonderful day.